This is the second lecture on differential equations, and we mainly did integration with a little bit of a twist. Right, now say you're given this is just an example of different functions. We have dy over dx equals f of xy. Now this is known as a normal form, and dy over dx equals f of x is known as the simple form. Now to solve these kind of equations, we first split it up. So we split it up so that dy over dx equals p of x over q of x. Now p of x and q of x are different functions. So let's say we have dy over dx equals x over y. Now we can split it up so that p of x equals x and q of x equals y. Now then we move it around to get all the x's on one side and all the y's on the other. So we have y dy equals x dx. Now with the dy and dx we simply integrate each side. So integrate each side, which gives us a half y squared equals a half x squared plus c. And then to finish it off, we must rearrange it so that we get y on its own. So we've just moved the half over and we square rooted. So we've got y equals plus or minus the square root of x squared minus 2c. Now this is a little bit of a trickier equation. So we have dy over dx equals y bracket 1 minus y close bracket sine x. Now here what we're going to do, we're going to pick up p of x. We need to pick a p of x and a q of x. Pick our p of x as sine x, and our q of x, which has to be underneath, as 1 over y bracket 1 minus y. Yeah, because we can't pick that because it would be wrong, because that would be a p of x times a q of x. So it's going to be 1 over this. Alright, so we've done that. And then we put each of the parts on each of the sides. So we have 1 over y bracket 1 minus y dy equals sine x dx. So now we integrate both sides. And what we do here is we split it up using partial fractions, which I said in the last video you need to learn for the rest of the course. Now, you can just Google it, that's a good thing on Wikipedia. So that gives us 1 over y minus 1 over y minus 1. Now, the reason I put a minus there is to make it easier, so that, well, when we integrate it, we find it's a log, and it just looks a bit simpler. You can, however, have 1 over y plus 1 over 1 minus y, that's just the same. And over here, we've integrated, and it's minus cosine x plus c. We have our constant over this side. Now, when we integrate these, we get log y minus log y minus 1 equals minus cosine x plus c. Now, what we should know is through the log laws is that when you subtract two logs, they divide each other. So I have y over y minus 1 equals minus cosine x plus c. And what I've also done is, just to make it look a bit nicer again, I've times all these, everything by minus 1. So that leaves cos x minus c is minus log y over y minus 1. Now this will give the inverse of this, which is y minus 1 over y. Now I've put everything to the e. I've raised everything to the e. So that gets rid of the log. And it creates an e function over here. So we've got y minus 1 over y equals plus or minus e cosine x minus c. Now what we can notice here is that we've got y over y and, well, minus 1 over y, which will give us 1 minus 1 over y. So we got, yeah, like I said, y over y minus 1 over y. Now, what we want to do at the end now is that get y on its own. Now to do that, first of all we've got a minus here, we should get rid of that and times everything by minus 1. So we're left with minus 1 plus 1 over y. Now nothing happens over here because it's a plus or minus, so if you times a minus by a minus makes a plus, you times a plus by a minus it makes a minus, so they're just the same. Now we can move the 1 over, so that'll be plus 1 over here, and we can, now we want y at the top, so we just flip everything over, find the inverse, and that leaves us with this. Now what I've also done actually, I've substituted to make it look a bit nicer again. E to the minus c, I've made that equal to a. So what we've got here is 1 over a e to the cosine x plus 1 equals y. So we've got y on its own. Right now, the last thing, if you're given conditions, at the start of the question you may be given a condition like this where y of 0 equals 1, which means if x is 0, y is 1. So I've got a little example here. You might end up with an equation like this, y equals ae to the minus x. So when x is 0, y is 1. So e to the 0 is 1. So a equals 1. Some also stuff is shown us, which I thought was quite useful, is special integrations you might come across. If you come across 1 over 1 plus x squared, that is the inverse of tan x. Yeah? And another one, the last one he showed us, was the integration of 1 over the square root of 1 plus y squared. Now y and x can change, there could be any letter. That's equal to arc cosh y.